Hello friends, how are you? In this video we will solve this problem. This is pretty easy problem, but these easy problems will help us to understand the machine language, and later we will slowly go to complex problems, and then we will also learn to make these programs by ourselves. Okay, so we are solving this problem, and you know the name of the book, Computer Science and Overview, and this is 109 page. Okay, I hope you got it. So in this problem, these are given. These are the address of the memory cell, and these are the contents of that address of the memory cell. So then it asked, and you know these are in hexadecimal, but actually this could be in binary. But to make everything compact, we use hexadecimal notation here. Anyway, so then it said, if we start the machine with its program counter containing 00, what bit pattern is in the memory cell whose address is hexadecimal 17 when the machine halts? And hopefully you know that when this command run like C000, the machine halts. You can check here in the machine language description. So C00, C is the decode and the value here, and the operands here are 000. That means halt execution. Okay. Anyway, so it said when after running the code, after finishing the whole program and halting in using this, what will be the value in memory address 17? Okay. So even there is no memory address 17 here, but you should know that the memory address is just not like, there is not like 5 memory addresses. There are many memory addresses, and 17 is one of them. But our program here is only contains, we can place our program in like only this within these 5 addresses. So this is a pretty little program. Anyway. So I wrote the whole things here. So since it said we have to start the program counter from 00, so this one, so we can place 00 here, and since we place 00 here, what will the processor do? It will take the first two hellos. Okay, first two hellos, like the value of cell 00 and the value of cell 01. And why it's taking two values? It's because the language we got in the book, using this language to make a full instruction, we have to use like two byte here. Like this one is 1 byte and this one is 1 byte, so 2 byte. So 2 byte makes an instruction here. Okay, and the processor we got is also designed in such a way that it takes 2 bytes at once. Okay, so that's why we will take the value of address 00 and value of address 01. Okay, so what the okay, so we have to place this value in the instruction register. Okay, so it's 1402, and after placing the value in instruction registers, immediately the value of program counter will get changed. Okay, so now it will be 02, and why 02? I already told you, because we already got the value of 00 and 01, so our program counter will, since it's keeping track of the next instruction, so this is why the value of program counter is now 02. So it's like, you can think like it's keeping one self, but actually it's not. Okay, so it's 02, and now the instruction will get executed. So what does this instruction mean? And to understand what this instruction means, just go to our description. Since see, the OP code here is 1. The OP code here is 1. And if we compare with this, so it said load, and these are the operands. So here 402 is operand, and 1 here is OP code. Okay. So load the register R with the bit pattern found in memory cell whose address is XY. So that means we got some value in memory address 02, and we have to load the value of memory address 02 to register 4. And here we got our registers. Okay. So what's the value of memory address 02? Check here. The value of memory address 02 is 34. And so we have to load this value to register 4. So now the value of register 4 is 34. Okay, because we got it because 02, the value of address 02 is 34, and the instruction said us to place the value in register 4. So this is why the value of register 4 is now 34. Okay, and now again we will go to program counter to check what instruction we have to execute next. So we got 02 here, 02 here. So let's go there. See, program counter is keeping track of these addresses. Okay, so 02 here. So we will now take 34 and 17. So the value of instruction register now will be 3417. And now we have to again change the program counter immediately by 2. So it will be now 4. Okay, and now we will execute this instruction. So what does this instruction means? So let's get there. The OP code is 3. Okay, so the OP code is 3. So it said store the bit pattern found in register R in the memory cell whose address is XY. So we have to store the bit pattern found in register R in memory cell XY. Okay. So the bit pattern we load in memory register 4. Now we have to load this value to memory cell 17, and this is the memory cell 17. So now there is nothing, but we know the value of register 4 is 34. So now the value of after executing this command, now the value of memory address 17 will be 24. Okay, 24. I hope you get it. Okay. So, and since our program we executed the instruction, now again we will go to program counter to check where we need to go. So it's 04. So let's go to 04 in memory cell. The value of 04 is C0, and the value of 05 is 00, and we will take both of them, right? So C000. So the instruction register now will be C000. Okay, and the program counter will get changed to 06. And what so after changing the value of program counter, anyway, so now we have to execute this instruction, and we all know C000 means halt. Okay, check here. C000 means halt execution. So our program will stop here. So after running this command, our program will stop. And in the question, you can see in the question, it just said that it asks us for only for the value of memory address 17 after the machine or when the machine halts. Okay, so our machine already halted, and as a result, we found that the value of our memory address 17 is now 34. Here is 34. I hope you get it, and that's the answer.